In this problem, we're going to see that we can combine algebra and logic to get some results that are very fascinating and very useful. In our case here, we're going to assume that x is bigger than 0, and we want to prove that x over the square root of 1 plus x is less than x. And from that, we want to deduce that the integral is less than this value here. And note that here, this looks like this function here, and this looks like the integral of this one. Therefore, we see that if we can prove this one, we can move to the integral, and we get the result that we need. So first, we're gonna prove this one here. There are many ways to prove this result here, but we're gonna use some simple algebra. Okay, we use what we have, and if we can't, we just cross multiply and we get the result. But let's start from here. We assume that x, so let's prove this first part here. Let's prove the first one. So here we have x is bigger than 0. So we want to have this 1 plus x. So we add 1 to both sides. We're going to have 1 plus x is bigger than 1. We need this square root. The square root is not going to change the order of our case here. So therefore, we take the square root of both sides. We have the square root of 1 plus x is bigger than the square root of 1, which is 1. And this is bigger than 0. Here, if we can flip, we're going to invert the order. Okay? So if we flip, we're going to have 1 over 1 plus square root of 1 plus x is less than 1. Okay? And we still have this is bigger than 0. Okay, now what can we do to get this result here? Since x is positive, we can multiply both sides by x, and if we multiply by x, we're gonna get x over 1 plus the square root of 1 plus x is less than x, and that's what we need. Okay, note that x is positive. If we had x negative, something other things could happen. Okay, now there are other ways to prove this result. You can square both sides and keep working until you get something that's logical, because we don't want to have this square root here. Okay, well, we can do it our way here. Next, we see that this looks like the integral of some function. Okay, remember that when we have a f, some function f is less than g, then the integral of f between some a, b, let's say for instance, is less than the integral of g. Okay, so if you have this one here, we can have this. So now we see that we can have this one as our f, and this is our g. And to do so, we can just change the dummy variable. Okay, we can say, let's do 2 here. We have t is less than the square root of 1 plus t is less than t for t bigger than 0. Okay, now we integrate between 0 and x. Let's integrate. So we integrate. Let's integrate 0 and x with respect to dt. Okay, between 0 and x dt. So once we do that, this is the value that we need. So this is what we need. And here we have a polynomial. So t is, we can integrate t and get t squared over 2 between 0 and x. And once we evaluate, we're gonna have this one is x squared over 2, and when x is 0, we're just gonna have 0. Therefore, we have the integral between 0 and x of t over 1 plus t dt is less than x squared over 2. Okay, and that's what we need. That's what we need. This is our aim of this problem, is to use algebra and use the properties of the integral to arrive at a result that might seem like scary or But this is very simple. Just using algebra and keep going, and using the laws of logic, we can arrive at our result here. Okay? And sometimes when dealing with these kind of questions, it's better to write the function as the integral between 0 and x of f of t dt. Okay? Think of x as being fixed, but it's changing. We fix it for a moment until we integrate, and after that we do with x what we want to do. Okay? So here algebra plays a vital role in this problem. Okay? We can also interpret this one. We can use graphing. We can graph the function and see the integral. What does it mean here? Okay? But for us, this is all we need now. Okay? If you see any mistakes or error, please let us know. We don't edit the videos. We let them as they are. Please comment, share, and subscribe. And I wish you all the best.